One of the first things that we did when we came here to Fernando was have a look around the coastline, and we saw dolphins jumping out of the water. Right up near the beach, we could see turtles poking their heads up out of the waves to take a breath of air, because of course they're reptiles. They've got lungs and they need to breathe. So we could see all these amazing animals. But then our friends took us around to one of the other portions of the island, and we found, just like we find in England, this kind of thing. We found plastics, marine plastics. And, you know, they took us through and they explained that these things, they wash up. They travel all across the world. They travel on the oceans from all sorts of countries. They come in Fernando, they come from Africa, they come from Asia. They actually come from the UK as well, which is a little bit sad to think what some of us are doing in the UK, dropping our litter, is ending up here and affecting those turtles. So we thought what we'd try and do is incorporate a bit of that litter into our next activity, our next experiment. If you live near a beach, wherever you're watching this show, you could do this. You could go and collect a little bit of beach rubbish like this, bits of plastic that really shouldn't be there. If you don't live near a beach, of course, lots of this plastic doesn't originally get dropped in the ocean. It gets dropped in the mainland, in the middle of the islands or the land or the country. The wind and the rivers can take it to the sea. So just because you don't live by the sea doesn't mean that picking up bits of plastic in your neighborhood isn't helpful for the animals that live in the ocean. Anyway, what we did is we took these bits of plastic, and very kindly the crew on the Oosterschelde gave me some little bits of metal as well. I've got some I don't know what you call these, bits of cans. You probably recognize them, you guys. Got some other little bits of metal, some clips and different things here, a little bit of wire, and of course, a single-use drinks bottle. Now, we know we've got a bit of a problem with these, don't we? We know that a single-use plastic is not a good plastic. Hopefully, everyone watching the
All right, we got a little pause in our experiment. Hopefully we'll get Stu back shortly. And right after Stu finishes his experiment, we're going to have a little Kahoot quiz together. So be ready for the Sea Turtle Kahoot quiz. As per usual, the class room that finishes in first can email us for their $50 Amazon gift voucher. We will do that Kahoot together right after Stu's experiment. And then we will wrap up today with our curiosity of the week. We'll get our answer to last week's curiosity, and then we will take a look at this week's curiosity. Stu just disappeared from backstage, which means they are just trying to reload. So we should have him back with us shortly. When the experiment concludes, we will have our Kahoot, and then we will get into our curiosity of the week. Here we go. I think I see Stu's back with us. Hey, Stu.
Hello, Joe. Sorry about this. I don't know whether you've explained, you guys, whether you've heard. We're actually using, you have told people about this, Joe. We're using this satellite technology. Not everywhere has the strongest internet signal. You might be lucky. You might be somewhere with really strong internet signal. We aren't in a place that's got strong internet. So we're using this device, and it's brilliant. But it's even this device is struggling every once in a while. So we were saying, we've got all of this plastic. We've got this metal. We've collected it up. You're going to do the same wherever you live, near the beach, by a river, in the park. Just in the street. If you live in a big town, a big city, you can still help the ocean by collecting up these things before they end in the ocean. Anyway, I've just taken my pen here and I've drawn, don't judge me for the drawing, folks, that's not what I'm here for. I've drawn a tiny little turtle on this piece of plastic. This turtle right here, this is going to represent my leatherback turtle. Now, you'll remember the leatherback turtle is the biggest turtle in the world. They can grow to weigh a ton. This little guy definitely doesn't weigh a ton. He's a tiny little baby. But I've chosen him to be a leatherback turtle because if you remember, they're the ones, the leatherbacks, are the turtles that can dive to over 1,000 meters down in the bottom of the ocean. Now, I don't know about you guys, but I don't get anywhere near 1,000 meters. The other day, I managed just under 10. So that's about 1% of the ability to dive of a leatherback turtle. So I got to say, that is an amazing animal over there. And they're really lucky that they exist here in Fernando, because this is a great place to be. Anyway, this is my leatherback turtle, this little guy here. I've taken a bottle and I've filled it with water. What I've done inside that bottle is I've assembled some of my plastics and some bits of metal too. I'll show you what I've made. I'm just taking it out now. I filled the bottle up with water, so that's going to represent my ocean. This is my ocean. So right here, we're going to say this is the surface where turtles come up to breathe. And then down here is 1,000 meters. If you want, if you've got a bottle back home or something you can use for this experiment, you can use a marker like I'm going to do here. And you can put lines on. You could do a little bit of research and you could draw a line up here and say, okay, that's as deep as an olive ridley turtle can go. And then this line right here, this is as deep as a green turtle can go. And you can do the research and you can mark that up and do a little scale on your bottle. When you've done that, you need to prepare something that looks like this. This is another one of my little turtles. This was my first practice one, so he's not quite as good, but it's a developing art. If I turn it around, you'll see what I've got here actually is the top half of a pipette. You might be familiar with these from school or your science lessons back in the day, if it's been a while since you've been at school. A pipette, by scientists use, they squeeze the end there, put it in the water, and it normally has a long end on it like this. And then this sucks up water and liquid. It's really good for doing plankton sampling. So if anyone out there wants to do a little bit of plankton sampling, I'm sure we're going to be doing that in the classroom soon. It's a really useful tool. I've used a pipette. You could use a pen lid if you haven't got a pipette at home. Anything that you can put in the water and trap air in. So it's open at the bottom here and it's sealed up at the top. So if I put this in this way, if I put it in the water opening first, the air is going to get trapped in here. I've got to do this carefully because if I put it in this way round with the opening at the top and I put it under the water, all of the air is going to escape. So I want to trap the air in by putting it this way. The metal that I've included on it, that's to help weigh it down because all of that air inside my pipette is going to make it buoyant. It's going to make it want to float. But I don't want it to float off. I want it to stay in the water. And crucially, I want it to stay this way round. I want the opening to be at the bottom because that's going to stop the air escaping when I put it into the water. So, carefully, being careful not to spill water on my laptop, I'm going to open this up. I'm going to take my lid off, remembering which way up I'm putting my little improvised loggerhead turtle. Here he is. I've got my opening at the bottom. I'm going to put it into the water. Now, I'm going to seal the lid up. You might have noticed that I've filled the water to the highest level I possibly can. I don't want any air in there if I can help it. You can see it's a little difficult, but you can just about see in here my little loggerhead turtle. There he is. He's at the surface at the moment, breathing. Remember, reptiles, turtles are reptiles. They have lungs just like us. When they're underwater, they're holding their breath. They're not like fish. They don't have gills. They're holding their breath all the time. So it's important our turtle can get to the top. What we're going to do now, though, is a little bit of physics. This bottle, I chose it carefully. It's quite firm, but it's soft enough for me to be able to squeeze it and compress it. The funny thing there is if this bottle was empty, I could squeeze it really easily. Because it's got water in, it's really hard to squash it. One of the amazing physics properties of water is that it doesn't compress when you squeeze it. Air, on the other hand, does. That's how scuba divers can take so much air in that tiny little tank on their back. One tank for a scuba diver has got enough air, as long as they're near the surface, for them to breathe for 2 hours in that tank. 2 hours of breath. Your lungs, if you want to join me now and take a great big breath, you can fill your lungs up with air and out. And you can do that again with me. And out. We can fill our lungs up with air. But when things go down, when a turtle dives down, the air in its lungs gets squashed like in a scuba cylinder. And it shrinks. So what we're going to do is we're going to use that physical property of gas. Gases under pressure can condense and become smaller. And we're going to squeeze the air inside our little made-up turtle. And we're going to squeeze the air so that it's so small, the airspace goes so small, it's no longer able to lift the turtle near the top. Because that's what's keeping the turtle near the top here. It's all that air trapped inside. So if I give this a squeeze, let me see if I can show you this. Squeeze, squeeze, squeeze. Oh, the turtle has gone all the way to the bottom. Don't know how well you guys can see it, but just... Oh, I've got to get my finger right. It's reversing. Just here, can you see? The air is getting smaller. And if I relax the grip, oh, too much, it gets bigger. So the air compresses underwater. If I let go a bit, my turtle, goes back up to the top because the air expands. And I can play with this. The more I squeeze, the lower the turtle goes. So if you've done your markings on the bottle correctly and your research, you should be able to map out where the turtle can get to, maybe add other turtles. Heck, if you're doing this from home, or if you've got a lot of litter lying around that you can make turtles from, you could make lots of them in the same bottle. Experiment with different volumes of air, different weights of metal, and see if you can get it so that when you squeeze your bottle, you get a leatherback turtle that goes to the bottom, like this guy, and then maybe one of the smaller turtles that only gets to here. All of these things, these are all variations that you can do.